People used to
Mhm.
talk about 5 years, 7 years, 10 years of life for new batteries. And
Right.
what we were able to showcase was that actually for the batteries that people are thinking have reached their end of life actually are nowhere near their end of life, and with the right technology and the right business innovation you can make them last much longer.
Welcome to the Environmental Transformation Podcast, where we bring you interviews with industry leaders, climate champions, sustainability practitioners, EHS and hazmat professionals making an impact in their businesses today. Each leader solving complex challenges and delivering solutions within their areas of expertise. I'm your host, Sean Grady, and thanks for joining us today. Before we jump in, make sure to follow us on your devices and visit my website at www.seankgrady.com and sign up for our newsletter and email announcements. Now let's get started.
Welcome to the Environmental Transformation Podcast. I'm your host, Sean Grady, and today's guest is Dr. Surinder Singh. He's the CEO and co-founder of Relyion Energy. Relyion Energy is a redefining energy management. They are redefining energy management through a proprietary AI-powered energy forecasting tool, energy management system, and battery management systems. So that's the EMS and BMS. By integrating advanced AI software and energy brain, so to speak, is the company enables owners, operators, and end users to unlock unprecedented value from power generation and utilization assets. So Dr. Singh has a distinguished career focused on advancing and incubating technologies that address climate emergencies with a focus on the fundamentals of science, systems engineering, and business models. He's also authored many publications. He's also has over 50 patents granted or pending in the climate tech. So he's a busy guy. He's lots of experience. He's also worked at GE and a couple other companies. He's also mentoring startups in the climate and energy space right now. And so we're really happy to have Surinder come on the show and talk about Relyion Energy. Welcome to the show.
Sean, thank you for the introduction and thank you for having me. Looking forward to the conversation.
Absolutely. So, why don't we step back a bit here and give the listeners a little bit of background on Relyion Energy and, how you got started in this space and, give us a little bit of background on that, if you could.
Absolutely. Yeah. So Relyion, actually, we started in 2021. So we're completing our 4 years. And what we pride ourselves with actually a very strong technical foundation that we've expanded towards business fundamentals and so on. And the three pillars on which we've built the technology is on energy forecasting or AI forecasting that applies to many different sections in the energy sector, whether that is demand, whether that is load, whether that is power production, whether that is renewable, so solar and wind and so on, battery energy storage or other energy storage devices. So forecasting related to all of them with respect to both on the production side, on the utilization side, as well as actually on the pricing side also. So there are things like, LMP and so on at the utility scale level, at the ISO, RTO level, that includes the pricing forecasting also. So we do that. So that's the first pillar, which is on the AI-based forecasting. The second pillar is on the energy management system, or the EMS in short. And there, what we are doing is actually optimizing the assets in terms of how you can maximize the revenue that you can generate from these assets. And these assets can be, whether renewable energy assets or even non-renewable energy assets as well. So, power production and utilization devices, that's what I put them into. And that again includes, solar, includes, conventional power generation technologies, including, fossil fuel power generation, including natural gas power generation, as well as energy storage. And the EMS is basically, if you're sitting on all of these assets and you want to produce power or consume power or store power at the most optimum periods of time when the pricing is high or the pricing is low, or when the carbon production limit is high, or you want to reduce it and so on. So how do you optimize all of these assets, and optimizing them in terms of their value stacking, in terms of their revenue generation, in terms of saving on transmission, distribution, or electricity bills if you're a commercial and industrial sector and so on. So that's the second piece, which it utilizes actually the first pillar, which is the forecasting. So the EMS becomes really exponentially more powerful when you're utilizing actually forecasting or bringing the forecasting into the EMS or the energy management services. And then the last piece, or the third pillar, last but not the least, is in terms of life maximization or asset life of the asset maximization. And in this particular case specifically, it is related to batteries. And that is where the edge AI device comes in for the battery management system, where what we have already shown with many, many patents that actually we've applied and from the company within a short period of time, we've published our results where we took batteries that were manufactured by other folks and that were close to their end of life. And we took those batteries and have published our results where we took them to 20 plus years of extended life. This is a game changer, if I may call it, actually, because this opens up a space where traditionally batteries were not open to. So what people used to think about is lithium ion batteries, maximum you can utilize them for is like 5 years, 10 years, right? And so what we've done is with these patents and publications that we've already published out in the public domain that have gone through peer review and other people have seen it, is that we can take new batteries or old batteries and make them last for 10, 15, 20 plus years of life in as a stationary battery energy storage system. And that's where the edge AI device or the BMS comes in terms of life extension that applies to old batteries as well as new batteries, independent of actually the battery chemistry, the battery type, the battery form factor. With nickel cobalt containing batteries or lithium iron phosphate or the LFP batteries that are cheaper to make and are growing significantly right now. So we can work with any battery manufacturer and with this edge AI device make them last much longer. So those are the three pillars of the technology. So
that's good. That's great. Well, I mean, you've made a lot of advancements. So I guess what I'll share with the audience here is about 3 years ago, I met Surinder, and we were the company I worked for was interested in investing a little bit with Relyion as they were growing their tech. And it was with the battery management system with the Edge program. And it was really fascinating to see what they were designing and essentially creating battery backup gensets essentially for alternative backup power. And they were using, recycling basically or reusing EV batteries to do that with this technology. And it was a really fascinating process. And the design and the technology you guys have put together to make those and produce those is really remarkable. And it was fascinating to see how you were able to, maintain and optimize and extend the life of these batteries that, like you said, they may not be able or capable of still like powering a car. But when you pull these together, stack them together, individually utilize the cells that do have the power through your tools, you're able to maximize the life of these batteries in a way that was like, okay, no one's doing this right now, at least that we know of. And it was really interesting. So I'm glad you brought that up. But, I think there was a lot of success early on with those systems, but something happened along the way that made you pivot a little bit, didn't it? And with these other two pillars that not that you're probably forgetting or you're still doing battery management, but the EMS and your forecasting tool is really showing to be a bigger game changer.
So, Sean, that's actually very interesting. So let me put it this way. I think actually, with the BMS and with the battery life extension, what we have shown is actually absolutely tremendous with respect to where everybody else was. People used to talk about, 5 years, 7 years, 10 years of life for new batteries. Right. And what we were able to showcase was that actually for the batteries that people are thinking have reached their end of life actually are nowhere near their end of life. And with the right technology and the right business innovation, you can make them last much longer. And so that is what we started with. And as a vehicle to demonstrate actually the capabilities of the BMS, which is the brains of the battery energy storage system using the human body analogy, right? So that was the key, that what we built is the BMS or the brains of the battery energy storage system. Mm-hmm. But when you're starting as a company, when you go out and speak with customers and so on, everybody would look at you and say that, show me actually that it works, right?
Right.
And when you have to show that it works, what you have to do is actually build the full product. And by building the full product, that is where, so even though our tech was on the brains with the BMS, but we have to build the full human body analogy. We had to build the full battery energy storage system,
Right.
so that people can actually put their hands onto it and believe it that yes, it works. And so what we did is actually, as a vehicle to demonstrate the benefits of the BMS or the brains, that is what we did. And we built full battery energy storage systems, where one of the things that we recognized in the very beginning also was that actually we were not going to be manufacturing battery energy storage systems or manufacturing batteries ourselves, right? I think there are a lot of big companies and very innovative and good companies all over the world that have significantly reduced the cost, over the last decades plus. Within the last few years, actually, the costs have come down by, 60, 70, 80%, and it has become really, really cheap with respect to lithium-ion batteries manufacturing. And so our innovation, which is demonstrated now, is on the brains, which is the BMS. And so what we have now extended to is showcasing that because of this brains that we've built, we can make the batteries last much longer, and we don't have to make the batteries, we don't have to manufacture the batteries ourselves. So whether these are the Teslas or the LGs or the Panasonics or the BYDs or the CATLs, you name it, any company that is manufacturing lithium-ion batteries, including, nickel, cobalt, NMC, NCA, LFP, LMO, right? Any type of battery material with all their pros and cons, right? Each of them have a certain space to occupy. What we're saying is that actually with our BMS technology, and on top of that, when you add the EMS and the forecasting, what we are doing is actually maximizing the value that you can extract from these assets. So all of the commercial and industrial sector, all of the utility scale sector that is using more and more renewables, using more and more energy storage, and actually fossil fuel power generation is not going away. Natural gas power generation
it's not going away. Yeah.
The base load has to come from that. And so what we are doing is now, if you look at the whole umbrella, the whole envelope, is what we're saying is we're optimizing the whole grid. We're maximizing the value for everybody involved, whether these are power generators, distributors, consumers, anybody and everybody. We're making the grid more efficient. We're making the grid more reliable. And we're maximizing the value of everybody who sits in this space, whether you're consuming power or you're making power.
Hello, ET Nation. I want to thank you for listening to the podcast. If you're enjoying the interviews we bring you, consider supporting the program by visiting my website at SeanKGrady.com and buy me a cup of coffee. Proceeds will go towards helping me continue producing timely content and offset production costs. I'd also like to take a moment and recognize a few of our sponsors of the show who have been amazing partners and are ET Nation legends. If you're looking for a drilling and environmental contracting firm to help you delineate the extent of contamination at your site, then look no further than Cascade Environmental. Cascade has over 37 offices across the country and offers a huge range of environmental and geotechnical drilling, site characterization, and remediation services. With their huge fleet of equipment, nationwide coverage, Cascade is a great choice to support your environmental and infrastructure needs. To learn more, check out their website at cascade-env.com. That's cascade-env.com. Hey, are you looking for an equipment rental company to help you with your next wastewater remediation or waste management project? E-Tank is the only environmental equipment rental company in the industry that offers 100% guaranteed certified clean temporary liquid storage tanks at no additional cost. This protocol gives peace of mind for the previous customer by limiting their downstream liability, as well as the future customer by preventing any cross-contamination for all of their rental tanks. E-Tank also runs a one-of-a-kind complete maintenance program for all rental items, including liquid-tight roll-off containers, fluid transfer pumps, and filtration items. The next time you are presented with an environmental challenge, call E-Tank to come up with the solution for your problem. I want to thank one of our sponsors, WasteLink. WasteLink is the all-in-one software platform transforming how environmental professionals manage waste, connecting generators, service providers, and disposal facilities in a way that is simple, connected, and transparent. Their platform helps streamline everything from waste profiling and routing to inventory management and billing, giving you the tools you need to operate more efficiently and reduce cost. Whether you're a generator looking for better options or a service provider seeking greater efficiency, WasteLink has you covered. If you're ready to take control of your waste management processes and optimize your business, visit wasteLink.com to schedule a demo today.
So this technology of like the BMS, the brains behind the operation, so to speak, of optimizing the use of the batteries and the cells and the power within it. Is this a technology that, maybe one of these big manufacturers could purchase to deploy to better manage the batteries they're producing now? Or is this like an add-on aspect after the fact? I mean, is this something that, could be deployed earlier in the process for, say, some of these big companies? I guess I'm just trying to understand, how they could be deployed. Is it after the fact, or, when the battery's over with, or could it be used, during its, initial optimization, initial use?
Oh, everywhere. Yes. So
Yeah.
there are multiple, portions of the technology, some more invasive and some less invasive. But what we are showcasing is that with the edge AI device and with the EMS and the forecasting, it's actually very, very minimally invasive. And it doesn't have to wait for the end of life. So it can work with new batteries, on day one, that are supplied by manufacturers, and we put our EMS software, and if needed, we can put in our BMS on the battery energy storage system. But the EMS is actually completely independent as well. So the forecasting is very, very, it's zero invasive, right? So the energy forecasting can be utilized by existing power producers and consumers as to if you know actually what the power demand is going to be tomorrow, what the power demand is going to be day after tomorrow, and when would be the best time to actually produce, if you have the flexibility to produce at different times of the day or consume at different times of the day or store at different times of the day, how would you actually utilize your asset more efficiently by having this forecast, which is significantly better than everybody else. And let me actually give an example just on the forecasting side. I don't know if I'm jumping around, but I'm super
No,
excited
you're
about
fine. You're fine. It's good.
about all the different things. Is we've published many case studies as well now, which are publicly available. Actually, many, I would direct the listeners to visit our website also, where we've given links to the different case studies. And we've done case studies with many of the the ISOs and the RTOs. We've published a KaiSo case study, PG&E with PJM, with ERCOT, and so on. And as an example, actually what we've, and over multiple years, and each of these ISOs and RTOs have their own forecasting tools as well, and they publish the day ahead market and so on, and the LMP forecasting and things like that and so on. And so with these case studies, what we've shown is, as an example, with KaiSo, over a 1 year period, actually less than a 1 year period, over a couple of 100 days, what we were able to show is that within a small subset of KaiSo, just looking at actually PG&E, we were better in forecasting day over day, cumulatively better by 300 gigawatt hours. Let me
Wow.
repeat that,
That's a
300
lot.
gigawatt hours. Yes.
Wow.
And
That's a
that was
lot
just
of
within, a
savings.
subset of KaiSo. Yeah.
Wow.
And when people are talking about, data centers, coming online and, needing,
Power.
significant amount of power.
Yeah.
And what we're talking about is just one example, a subset of, KaiSo, PG&E, where 300 gigawatt hours we were able to demonstrate that we were better by 3x overall versus KaiSo in terms of our forecasting with respect to what the demand is going to be.
Well, okay.
That,
So
that is actually very small.
but that's great information, and it's interesting case study. So How did PG&E respond to that? Did they be like, wow, oh my gosh, we've got to have this technology, or what did they say?
Yeah,
Or-
so that's actually a very interesting question. And so we just recently published this study, and I think it's getting a lot of traction, and I'm getting a lot of inbound with respect to requests to find out how this can be actually utilized even further. And
Mhm.
what I was going to say is that when I paused, is that this was actually one of the smaller portions of the case studies that we've shown, or the benefits that
Mhm.
we've shown. We did PGM and we did ERCOT, and when we did it for the all of ERCOT, for one of the years, I believe this was 2024, we were 13x. So with Kaiso, I mentioned
13x.
3x
Wow.
actually for that case study. With ERCOT, we were 13 times better. This is 1300% plus better versus actually the predictions or the forecasting coming from ERCOT. And right
So,
now, this is very relevant because, as you can see, there are heat waves going around all of North America, with significant portion of the US and Canada, where we're talking about PGM and ERCOT and so on. All of them actually going through significant loads and load shedding and so on.
mhm.
Now, when we are able to forecast and predict what the demand is going to be day in and day out, and be better by 13x, the benefit of this is limitless.
Yeah.
The optimization of this is limitless, and so you can have a more efficient grid, and you can actually make a lot more revenue and profit when you utilize these services.
Yeah, I mean, yeah, totally. Like, the efficiency opportunities are massive. And so, the forecasting tool works, and it's actually, identifying when the peak demands are, or when it's going to be lower demands. And how does the utility take that information and act on it in a proper way so that they can adjust their systems to take advantage of either the savings or the increase there? Is there another step here that's part of this process that we get that information for the forecast, now we need to adjust, now we need to actually do and make the changes? How does that work?
Right. And so maybe the one example over there is, so I'll pick on a very specific case which happened actually not too long ago. So just about a month or so ago, what happened in Texas was, there was, towards the evening, there was a significant peak that happened with respect to power spiking.
Mhm.
And what everybody thought is that, okay, this is a huge peak that has come, and everybody discharged all of their assets with respect to the batteries that they were sitting on, battery energy storage systems, right?
Mhm.
Thinking that this is actually a big peak, and so all of the systems were discharged. But that was only a small peak, that nobody knew that there is going to be a much bigger peak that is happening later on. And later on, a
The
much
peak,
bigger spike happened,
and there
and
was not
all
enough
of the
power.
batteries were already discharged.
Ah,
So there was no power that actually they could have, if they waited, and if they recognize that this is just actually a pseudo peak, and there might be actually a much bigger peak or much higher power demand that is going to happen later, they would have people would have waited on it, made more money by discharging it later, and
right,
also actually made the grid much more efficient by discharging it later. The
right,
prices spiked to like $4,000 a megawatt hour, where typically the prices can be as low as a few dollars a megawatt hour. So
right.
imagine how much efficiency losses took place, and how
Mm.
much actually, what's the right way to say it is, how much revenue or profit loss that took place,
Mhm.
because you didn't know that actually there is a much bigger peak that is going to happen later on. Now, how does it tie to actually our tools, right? So it's not only the forecasting, but it is also the EMS as well. So the forecasting puts the EMS on steroids, so as to say. Traditionally, the EMS, or the energy management systems, are kind of like playing a little bit on the blind, where what they're doing is actually finding out, if the let's say, if we take the specific example of peak shaving, right, a smaller subset, where the EMSs, how they operate is, they would say that at a certain, when a demand or the load increases of at a certain, reaches a certain threshold,
Mhm.
then the batteries should discharge, and when it reaches a threshold on the low side, then the battery should charge, right? But they're kind of like sitting in the blind, because your load can actually be very different at not only different times of the day, but different months of the year and different seasons of the year. So if your EMS is operating just on a fixed load based peak shaving or a time based peak shaving, you're losing out on all the efficiency and all on the power savings that you can do if you operated the EMS more smartly. And what we've done is, by joining the forecasting along with the energy management system, we're able to maximize again the savings or the revenue that you can generate, or utilization of your asset is much more powerful than what would have been traditionally. And so there, as an example, again, as a case study, what we did is we took an example for a grocery store. We've spoken about utilities. Now let's talk about actually, a commercial and industrial sector as well, right? We took a grocery store example where we took solar and storage use case, and for the peak shaving as an example, where when the load was high, the batteries would discharge, provide the power, so that your demand charges or the time of use electricity bill goes down, right? And you would charge when the pricing is low and the demand is low, so that you don't hit the high demand charges, right? We operated the same system under two different scenarios. One is a traditional EMS, which is based on load based peak shaving, and then an EMS, which is Relyion based EMS, which has the forecasting and smartly adjusts at different times of the day and different days of the month and the different seasons of the year, to find out what is the right place at which it should be doing the peak shaving. The difference was huge. So what we did was, what we found out, that if the return on investment for a traditional scenario was like 50 plus years, which is meaningless. The batteries would not last 50 years. And in Relion's case, we were able to actually have a return on investment in less than 3 years. So it was about like 2.5 years. And so what that means is, if the batteries were on the other side, when we're saying actually that we had shown that we can make the lithium ion batteries last for 20 to 30 years, what that means is, by making an investment where you did a return on investment in as short as 2.5 years, for the rest 18, 20 plus years, you're generating money, you're making money, you're not sitting on a dead asset, which is a traditional scenario. Whereas here, it is making money for you. By saving money, you're making money.
Right. So the difference between, say, like a traditional EMS and the Relyion EMS is really the brains behind is the forecasting tool, and this and your, I guess, innovation around the design of it, right?
Yes, absolutely.
That's great. Awesome. When we look at these types of tools, can you talk about how Relion's EMS supports the applications a little more? Let's double click a little bit more on this peak shaving thing with EV charging and the microgrid resiliency. Talk a little bit more about, how does that work, and how can, Relion's EMS system, help these types of microgrids?
Absolutely. Yes. So there's many different use cases. Actually, time of use is one example, with demand charge reduction, another example, peak shaving, solar integration or renewable integration, backup power, actually, where, it's almost like, you can treat them as huge UPSs, so as to say, right? So if the power, shuts down, or, PSPS events takes place, public safety power shut off events takes place, right? And you need backup services. So there's the backup power. These are called, traditionally, these are like the BTM services or behind of the meter services, right? And then there is the front of the meter as well, with respect to frequency regulation or, voltage regulation and so on. So all of those that tie into these different use cases that we can provide for.
So you talk a little bit about, Relyion is hardware light and you're battery agnostic, on the BMS. So why is that? And what's, is that an intentional design choice? How does that help customers? And wouldn't you need to deploy your technology partners in that space to really, adopt some of the technology with you and their products to be a team,
right,
in making this work?
So there's two portions in this question, actually. So one is on being hardware light, and second is with respect to being technology agnostic, right? So on the technology agnostic side, one thing that I mentioned earlier as well is what we wanted to build since the beginning itself was, we started with the assumption that the technology evolution is going to take place, right? With lithium ion batteries, they're called lithium ion batteries, but they're not just one type, right? So there's many different permutations and combinations that have taken place within lithium ion batteries, right? Whether that is because of the chemistry or the form factor, the nickel cobalt containing ones, the NMC, the NCA, there's the LMO, there's the LFP, which is the lithium iron phosphate, and so on. And different, actually, within the same battery materials, different ratios in which actually these materials are also used, right? So there's many different flavors. And so that is the current status of the technology, and that it is not going to stop over there. The technology evolution is taking place. There are significant and very important innovators, people and companies that are there, and technology evolution is going to take place. So if we're building a BMS and a EMS technology, that has to be independent of these different sources, right? Different companies, different battery materials, and so on. So what we started with, the assumption was that we have to build a technology that should be applicable to all of these battery chemistry types, and so on. And that is why we started with that assumption, and we were able to build a technology that can work with all of these different types of chemistries and form factors and different sources. So that is, and how we were able to do that was because we went away from a traditional mindset where the technologies were built on a thing called SOC, or a parameters called SOC and SOH, which is the state of charge or state of health, which are, to simplify it, it's just ratios of parameters at that take the ratio of the capacity at different times of the life of the battery, in terms of state of health, and in terms of the state of charge it is at that particular moment of time. It doesn't have a physical significance. So these are actually built on empirically derived models. And so when you're running actually a battery with a BMS that is dependent on these empirically derived models, then you're limited. It doesn't have a physical significance. And these batteries, they age at different rates. So even if you take like a lab scenario, right? If you take batteries that are manufactured by the same manufacturer, same chemistry, coming from the same batch, and then you put them into a lab environment, by running them under same temperature conditions, same charge and discharge cycles throughout, day in and day out, still, if you take 100 different batteries or 1,000 different batteries, they're going to degrade at different rates. There are intrinsic factors that make the batteries degrade at different rates. And on top of that, then there are extrinsic factors due to which actually batteries would degrade at different rates. So by that, what happens is, if you've built a BMS technology that is dependent on the SOC and the SOH inherently on the ratio of these parameters, which do not have a physical significance, you end up with a brain that is trying to control these individual battery components that are all degrading at different rates, and you're limited by the worst performing component, and the bad apple spoils the whole bunch. So the problem keeps on becoming worse and worse as the more you age. So what we did is, actually, we went on to develop this BMS technology that goes away from that, goes away from the SOC and SOH kind of, these parameters that do not have a physical significance. So we go down to the physics of how the batteries actually degrade, how the batteries operate, and we make them actually charge and discharge in different manners, so that we are accounting for the differences in how they're aging on the fly, rather than actually looking or being dependent on just the history or the past on empirically derived models. We look at actually the current status of the battery and the system altogether, individual components and the whole system altogether, and operate them differently on the fly. Rather than looking at the past, we look at the present and how they would evolve in the future.
Well, how long does that assessment take to kind of evaluate the different batteries that you are, essentially going to manage in that space? Like, how long does it take for the system to kind of evaluate each of the batteries in that way based on its characteristic and everything else? So what's that look like?
Very important question. And actually, what we do is, actually, we do it on the fly. So it's not that actually you need a lot of data to run these batteries and then find out actually how they're degrading and then actually operate them in a different manner. What we do it is, we do it on the fly. So We start with the stock model. When you're starting with actually a new battery of energy storage system, you start with actually a stock model. So when you start, all batteries, they start with actually a very flat line, and then they start crashing. So the beginning is actually very uniform. So you start with a stock model, but then it keeps on adjusting on the fly, and that's how we are able to actually, not wait for huge amounts of data, and correspondingly not wait for a huge amount of time before we can actually start operating. We can start on day one.
Okay. All right. What does it look like for a customer who says, "Hey, Surinder, I want Relyion Energy's, EMS, BMS, and forecasting technology to come and evaluate my operations to see what you guys can do to help us, optimize our energy usage, save money, and generate revenue, whatever. It depends on if I've got a bunch of batteries I can generate revenue with, right? I mean, tell me how that looks. What does that look like for a customer?"
Right, there's multiple ways on this. So one of the easiest ways is that actually we can operate in a shadow mode, right? So, and by that what I mean is, if you have an existing setup, an existing operation, and you're utilizing actually a certain technology, you don't need to modify anything at all. What we are going to do is we can operate in a shadow mode, where you don't have to change anything that is on the system itself, but you can actually recognize, if we were maintaining and operating the whole energy management system and the forecasting, then what it would look like, right? So the customer can recognize or start seeing the benefits directly in parallel without even modifying their system. That is one way to do it. Second way is that we can actually get the data from the customer, and they can anonymize it, they can redact it in whatever form and so on. We can take the data and run studies on our side, and give the results back to them. So for example, in terms of the forecasting study, right? So we can give the results back, and they can compare the results, day in and day out. They can do it for a week, 15 days, a month, and so on. When you can continuously see that there is, we're significantly better than what they already have, or versus what exists in the market, they're automatically going to get converted. So these are the least invasive ones. And then the ultimate goal is that obviously we start operating or managing the assets ourselves. We provide the forecasting tools, we manage the assets in terms of the energy management system, and we maximize the value and the life of these assets moving on for the customers.
So in that scenario, the last scenario there, are you guys, is this like a cloud service? Is this on premise? How is this tied into their system so that you can actually start managing this?
Right. So the AI forecasting and the EMS is completely cloud based. The BMS side is an edge AI device, and that's where actually the hardware light component comes in, where you had asked earlier, which I think we started discussing other things. But the hardware light portion is the edge AI device, which is actually a small controller that can snap onto or sit on the outside of the battery energy storage system. And that edge AI device, or the BMS portion, is the only portion that is specifically related to the batteries. But the EMS and the forecasting applies to the batteries, but many other types of assets in addition to the batteries as well.
Okay. All right. Wow. I see here you've generated about $1 million in revenue from early adopters. What's the next commercial growth and market expansion for you guys?
Right. So, and what we did as an example is we showcased our benefits on the BMS technology. So we use the battery energy storage systems as a vehicle to demonstrate the benefits of our BMS and the EMS. Now, the next stage, the growth of the company, is with respect to all of the huge waves that are actually simultaneously happening right now, with the data center growth, with the power demand growth, with the electrification of everything, with more renewables, with more decarbonization, more sustainability. So there's so many multiple waves that are happening actually right now, and we're sitting in the middle of it, where our cloud-based AI forecasting and the EMS and the edge AI device BMS can significantly increase the value at commercial and industrial scale, and actually going into the utility scale. The utilities have traditionally, and rightfully so, have been very risk averse. They want to see the technology out in the field. They won't be the first ones to actually adopt a new technology. What we've done now with significant patents actually that have been applied for, we have significant data that is already published that have gone through peer review. We have systems that have already been sold to different customers. So with all of that actually already achieved, now the next exponential growth is just about to happen.
Wow. Yeah, no, that's really good. I mean, when you think about it, I mean, is it the utility scale the biggest, opportunity for you guys in a sense because of the large volume of energy that will constantly being, either delivered, just, through distribution, transmission? I mean, it seems like that's probably the most lucrative or the most, impactful type target for you guys in a way, right? I mean, maybe I'm wrong here, but it seems like that would be it.
What I would say is I think actually there are kind of like three sectors that are really important and are all going to grow. There's the utility scale, which you as rightfully mentioned. There is the data center, kind of like the subsector, that is significantly
They're the
growing.
consumers of the energy, those
Right.
guys, right?
Yes, absolutely. And then I wouldn't disregard actually the C&I sector. This is more like actually, the distributed energy kind of analogy that we can utilize from, what happened with the internet as well in the past. And so the C&I sector with the distributed kind of grid is going to also significantly grow and see huge benefits. What we have to do is actually to have an efficient and an optimized grid. We need to make sure that there are not only we're looking at the system holistically at utility scale level, but also these kind of like small, if you can call it the nodes, right, or the neurons at different places. So these can be optimized and make the grid even more efficient.
Well, how is Relion's approach to forecasting different from traditional grid or ISO forecasting methods like Casio?
Yeah. So what we've
Queso.
done is actually we're looking at it actually again the physics of every system. So rather than looking at it just as a just blindly finding out what the next number can be, in terms of just looking at it from a mathematics standpoint.
Mm-hmm.
What we look at it is from a physical and a physics standpoint. I call our system, and there are actually this terminology has been used or have been started. It's starting to get used more and more right now is physical AI. So what we are doing is actually we've brought in the physical AI with the physics also along with it. So what we're doing is we're looking at it, the whole energy sector, from the standpoint that there are these individual parameters that all are really important to look at. So whether these are the temperature, whether it is the weather or how the batteries operate, how the solar power generation takes place, and so on. So we're looking at it from a physical standpoint with the physics involved, rather than just predicting actually a number from a mathematics standpoint. So there is a ML and AI portion that looks at the physics of the system, and that's how we're able to forecast it better.
It seems to me like, some investors, like utility scale type investors, should be really thinking about reaching out to talk to you guys about the technology, or some of these solar power battery backup type, companies should be reaching out to find out how they can, work with you to utilize your technology. I mean, what am I missing here? Who should be a customer? If you're an investor, or a partner who's listening, what makes now the right time to work with you guys?
I think this is actually a really good time with respect to all of the changes that are taking place in the grid right now, with the data center growth, with the Gen AI growth, with more renewables growth as well, and with climate changes also taking place. So we're at the right place at the right time. So we're enjoying the benefits of being sitting on these right waves that are taking place at the moment, and just the future is amazing.
Well, I mean, if you were to fast forward 10 years from now, how will the platform like Relion's reshape the relationship between energy producers, consumers, and the grid?
I think the way the sector is growing is, I don't think anybody would doubt the fact that this is going to be big from multiple fronts, right? What is important to recognize is that there are going to be multiple winners in this space. This whole pie is so big that actually each of those winners is going to be big themselves, and Relion is what we are making sure is Relion is one of them.
You're
And
getting a piece of the pie, right?
yes. So yeah, I think the future is amazing, and we're just making sure we're doing the right things at the right time.
Well, I was just curious because one of the questions I didn't ask, which was like, I'm assuming you get competition in this space too. There's other, companies that are doing something similar to, or maybe it's, exactly the same type of similar type thing. I mean, so what does that look like from the landscape from your perspective as well? Does anybody compare to you guys, or do you have such a kind of edge on everybody else right now that, you kind of are in the driver's seat here?
Right. So I think competition is good. It makes everybody better, and you always stay on your feet and become more innovative, and you run faster, right? So competition is good. At the same time, though, what we saw is, I think there are a lot of companies that are kind of like operating in these silos. There are
Mhm.
companies that are just working on, the battery analytics side. There are companies that are working on the battery, second life or repurposing side. There are recycling companies, right? There are companies that are on the forecasting side and so on. But and there are, energy management services companies as well. So, but all of them are operating in silos. There was a huge need that we saw, that there needs to be a holistic solution that makes all of these things actually become better. So instead of being, one, you can become 11s or 111s and so on, by combining all of these things together and be, the best at actually each of those things as well. So there is a lot of competition, and that is a good thing. It makes us better, and hopefully makes others better as well. And what we are doing is actually doing this more holistically by looking at the whole system problem. That is where my background comes in. Actually, I'm more like a systems engineer and a techno-economics background and so on. And so we're looking at the whole system together, and doing this holistically, which nobody else is doing.
So if you're like a utility design engineer helping utilities build their networks and their grids and everything, is that type of a firm somebody that should be reaching out to you as well at an early stage to help, implement and deploy this technology in the design?
Absolutely. What we can do is we can help with respect to, how much load is expected to increase at, various places of the grid, where would be the right place to put, more power generation, or more, if a data center needs to be put at a certain location, we can find out whether that is the right place, or are there other alternative places. What are other technologies that should be put in, and what their right sizing should be, right, in terms of design. Before even going to operation, we can help on the design side, and then going into the operation side as well. How do you optimize all of the different consumption and generation devices that you have, and how do you make them last longer? How do you minimize your degradation? How do you maximize your power savings and so on? So all of that actually, at various stages, design, operation, and life, all of that actually we apply at multiple places.
Yeah, this the utility energy boom is what I would call it, that's going on right now across the US with, the demand of power from all these data centers and the, for AI. It's remarkable right now what we're hearing from the utility sector is like there just isn't enough engineering firms, production firms, design, firms, whatever, to help them meet the demand that's already out there for all the data centers that's being required or requested to be built across the country. It's amazing, and it's going to have a big. And there's not enough power. That's the other thing, is there's not enough power to meet the demand as well right now. So
Yeah.
anything these guys could do to optimize and become more efficient would be, in my mind, a good move, right? I mean, that
Right.
way they're taking advantage of the existing power they do have and using it more efficiently to meet the demand.
Right. And there are differences with respect to what the data centers of the past were versus what the new data centers are and how they're actually being utilized, right? So, traditionally, the internet, the data center load used to be, very kind of uniform. But with now the Gen AI, with the AI training and so on, there are these, data centers that have these, power spikes that happen, so frequently and at very high loads, that you need to have solutions that are more innovative with respect to how do you get all of these power spikes that are happening so frequently and big spikes. How do you utilize assets, or how do you bring assets that are most efficient in terms of providing that kind of load which is changing at the least amount of cost? And that is where again our innovation comes in with the forecasting, the EMS and the BMS, as to how you can utilize these assets most efficiently.
Well, it sounds like, I know for the listeners who've hung on for this interview, and I appreciate you all. This was a very technical conversation around, some technology and solutions and software that's really helping energy systems become more efficient. And a lot of times, if you're not a real techie or a real engineer in this space, it might get hard to really conceptualize it all. But I know that Dr. Surinder Singh here with the Relyion Energy is doing an amazing job of creating tools that I think will help not only, companies across the country become more efficient, but, also help deliver power in a more efficient way, in a cost-effective way for us. And so how would be the best way, Surinder, for someone to get a hold of you? I'm thinking of, some company that needs your help. What's the best way for them to
Absolutely. I
get a
would
hold of you?
say, anybody who would like to speak with us, our email to reach out is contact us at relyonenergy.com. And we would be glad to speak with everyone. Looking forward to it.
Yeah, that's great. Well, you will make sure we promote this, on when we release the podcast. This will be a great episode for people really, challenged with how do we deliver more efficient power with the existing assets we have. This seems to be a solution that could really help, not only through battery backup, batteries, management, but this EMS and your forecasting tool, I think is a game changer. So really appreciate you coming on, Surinder, and explaining a little more in depth about this. And I'm sure for the listeners, there's a lot more detail that I know he could get into, because I've actually had other conversations with him, and he can be very specific about the engineering design behind this stuff, but it's more than we can cover today. But thank you for coming on the show, and we really appreciate you. And best of luck with the Relyion Energy and where you guys are going.
Thank you, Sean.
Thanks for listening and watching the show. If you enjoyed the show, then please share it with your friends and coworkers on social media and tell somebody in person. Thanks for being with us, ET Nation.